Hello game developers. In this tutorial we're gonna breathe life into our player character by animating him. In particular, we're gonna make him run, jump, slide, and fall using the Unity animation system, previously called Mechanim. We'll also code his jump behavior in tandem, so let's do that. We'll begin this tutorial by going over a mini introduction in 3D computer graphics so that you know the underlying process of how a 3D character is animated, not just in Unity but in game development in general. Otherwise, it would just look like we're clicking buttons. This makes it difficult to avoid some technical jargon related to 3D computer graphics. So be sure to check the articles that are included in this tutorial to know more about the subject. So go to the models folder in our project assets folder and then locate our player character model inside the uCharacter folder. Let's expand the model files and select the character mesh. Drag the preview bar up like so that we could see our mesh in the inspector window. Now this character model, which I believe was the official Unity mascot back when they released Unity 4, started as just a digital 3D sculpture like the one you see in the preview right now by the 3D artist who created it in a 3D modeling software like 3ds Max or Blender. As you can see in the wireframe view of our character, the 3D modeling software or sculpting software stored the character model as a bunch of subdivided triangles with edges and vertices using sophisticated computer graphics algorithms. For example, here is showing that this character model is comprised of 8088 triangles and 5001 vertices. These triangles and vertices form the outer surface of our character model, which is called the mesh or skin in computer graphics. However, that's not enough for us to animate our character model. What we need to do now to be able to animate our character model is create a skeletal map of interconnecting bones and joints inside this mesh that mimics the anatomy of humans. And this is done in a process known in the animation world as rigging, which is usually tedious depending on the complexity of the 3D model. However, luckily for us, Unity has automated the rigging process so that we don't have to animate our 3D models ourselves. We could just import pre-made animations from outside and rig them into our character skeletal map in a few simple steps. So let's rig our player character. Select the character model from the project assets folder. From the inspector window, click the rig tab. Under animation type, select humanoid. Tick the optimize game objects box so that it doesn't create any unnecessary additional files. Hit apply. Now what Unity has done is that it automatically created the bones and joints definitions for the player avatar and mapped them onto their designated positions inside the player avatar under what is known as a skeletal map. And if you want to see the skeletal map of this player avatar, go to configure from the avatar definition. Let's see our player from the front. So this is the skeletal map that the humanoid rig has created for our player avatar. You can see that it mimics human anatomy, hence it's called humanoid rig. And on the right you can see where each bone is placed on the player avatar denoted by the target sign. Below are the definitions for the bones. Each bone is represented or defined by a transform object that has a position, scale, and rotation. For example, if we click on the upper arm bone, we can see its transform values here. Okay, finally, on the left, Unity has created this intricate hierarchy of game objects for the bones. This is because some game objects, in this case bone game objects, have to be grouped together so that they can move together. For example, if we click on the right hand bone transform game object, we can see that it's children of the right elbow game object. So, if the player avatar's right forearm moves, then his right hand must move as well, just like a real life. Okay, hit done and then go to the animations folder inside the uCharacter folder. Here are 4 pre-made animations that I have imported from a website called Mixamo and put in your TempleRun clone starter kit package. What we're gonna do is give each of these animations a humanoid rig here in Unity, just like we did with the player character model. But first, let's go to Mixamo and see how we can download different animations for them to be used with Unity. Open up your browser and go to mixamo.com. Sign up for a free account. I believe that they have a paid membership that has more animations and features, but a free account is more than enough for this course. Once you're logged in with your account, you can view and download thousands of animations. Let's look for a running animation and see how we can import it in Unity. I'll choose this one, and I believe it's the same one included in the starter kit package. Hit download. Under format, choose Unity FBX. Let's have it without skin and at 30 frames per second. Now simply drag and drop the downloaded FBX file into your project assets folder, or go to your project assets folder and right click, Then choose Import New Asset and locate the animation FBX file. Now let's rig our first animation, which is the running animation, named xbot at running.fbx. As you can see, it has the same import settings as our player model. Go to the Rig tab and select Humanoid, and also tick the Optimize Game Objects box. Hit Apply. Now go to the Animation tab, and we can play our animation in the preview to see how it's gonna look. If you wanna see our player avatar instead of this ragdoll model in the preview, go to this little cyan avatar icon here and select Other to choose our player avatar model. Let's look for it here in the search bar. And here it is, being previewed for the animation. You can hit play to see him running if you want. Now let's apply some necessary settings to our running animation. First, tick the loop time box because we want the running animation to be constantly looping and not just be played once. And also tick the bake into position box for the root transform rotation option because we don't want the animation to change our player's position or rotation. And select based upon original. Scroll down and hit apply. And we're adjusting these options because these animations are not specifically made for our character. They are imported from somewhere else. We have to play with the settings to make them work properly on our character model. Now let's select the jump animation and give it a humanoid rig as well, with this game objects being optimized. You can see that it looks funky in the preview. This is because we haven't yet given him a humanoid rig. So go to the Rig tab and select Humanoid, and tick this box. Hit Apply. Go to the Animation tab and bake him into position the same way we did with the running animation. This time, however, we'll bake him into position along the y-axis as well. And let's not tick the looping box because this animation should be played whenever it's called only. Hit Apply. Let's play the animation in the preview. Actually, I would like his jump distance to be a little higher. So let's offset it in the y-axis by say -0.2. This looks good. Hit Apply again. Now let's go to the slide animation and repeat this whole process once more. Choose a humanoid rig, optimize game objects, apply the changes. Go to animation, bake his rotation into position and also his Y position. Don't forget to select original, hit apply. Finally, we'll do the same with the trip animation. And let's not bake him into position this time. We'll see if we have to do that later. Okay, now we're ready to animate our player using these animation clips. So, let's go to the main directory for our project assets folder. Right click, go to create, animator controller. Let's name it player animator controller. Double click on the newly created animator controller and it will take you straight to the animator window. The rectangles you see on the screen right now are called finite state machines or just animation state machines, and they are a popular and useful idea in computer science in general, not just in animation and game development. Animation state machines allow us to transition between several animation clips in a specific sequential order that we're gonna design ourselves. So let's begin the sequence with the running animation by dragging it from the animation folder inside the uCharacter folder and dropping it into the animator controller window. We can see that the running animation state is colored orange, which means that it's set as the default state. And we want that because our running animation is going to be played constantly in a loop. Now let's drag the jump animation into the animator controller and create a second state. Let's see. Is it possible for the player to jump while he's running? Yes, of course. Then we can transition from this animation state to this one. So right click on the running animation state and select Make Transition and connect the unidirectional arrow to the second state by clicking on it. Now we shouldn't be able to transition from the running animation to the jump animation willy-nilly. This transition needs to be triggered by an event, like if the player presses the space key, for example. Now let's go to the parameter tab here on the left and click the plus sign and then select trigger. And let's name it is jumping. Now this is technically a variable, so be sure to follow the same naming conventions that we have agreed on earlier in the course. Now click on the transition arrow and under conditions in the inspector window, hit the plus sign to add a condition and then select is jumping. And now we cannot move from running to jumping unless this is jumping event is triggered, which we will code in our player controller script shortly. And also untick the has exit time box. This means that this animation is interruptible and should immediately transition to the other animation state once the trigger is set. Lastly, I'm gonna make the transition happen earlier in the running animation by dragging the transition window a little to the left, and also make the transition value steeper and hence quicker between the two states. Now what do we do once the jump animation has finished playing? Well, we should transition back to the running animation state, right? So let's make a transition from the jump state to the running state, but this time with no conditions. So once the jump animation is done playing in this state, it will default back to the running animation state. Let's see this transition in the preview. Well, to me it seems like the two animations are overlapping a little too much, meaning the second animation starts playing before the first one is done playing. So let's make the running animation happen earlier in the timeline. And also, let's shrink the transition gap between the two animations. Let's see it in the preview. This looks very good to me, and you could play with these settings until you reach your wanted result. Also, if you feel like you've messed up your transition timeline or settings, then click on these three vertical dots and hit reset to go back to the default settings. Now let's repeat the same process for the slide animation. Drag it into the animator controller, and let's make a state transition from the running animation state to the sliding animation state, because our player should be able to slide while he is running in the game. We'll also create a new trigger event specific to this transition, which we will call sliding. Now let's click on the transition arrow from the running state animation to the slide state animation and set the trigger condition to sliding from the conditions list. Let's untick the has exit time box, and also let's make the transition happen a little quicker between the two animation states. You could make it perhaps a little slower or a little faster, up to you really. And of course, once the slide animation is done playing, we should transition back to the default running animation state automatically with no conditions. Now let me ask you a question. Should the player be able to jump while he's sliding? Meaning, if the character is sliding and the user has decided to make the player jump, should the sliding animation be interrupted midway through the sliding action? Well, in the real game that's possible. So let's make a state transition from the sliding animation state to the jumping animation state. And we'll also use the isJumping trigger to allow this transition to happen. And this transition shouldn't have an exit time. Let's shrink the transition window between the two animation states. Now we're technically done creating our animation states for this tutorial, but let's drag the trip animation to the animator controller and get it over with, so that we don't have to deal with it again. Our plan is to play the stripping animation if the player hits an obstacle or falls down a broken bridge segment. And this could happen, of course, if the player is running, jumping, or sliding. So let's make a state transition between each of these animation states to the trip animation. And let's create a new trigger and call it stripping. And go to each transition to the trip animation and set this trigger. Also, none of these transitions has an exit time. Finally, let's make a transition from the trip animation state to the running animation state. And this is gonna be invoked when the player dies in the game and then is respawned in the scene. And we'll program this part in a couple of tutorials. So let's create a new trigger and call it spawned. And set the transition condition from the trip state to the running state to be spawned. And of course, it shouldn't have an exit time. Also, let's increase the speed of the jump and slide animations by 30% because our player speed is gonna be incremented as he runs further and further. So we want the animations to also look fast. Let's click on the jump animation state and make the speed 1.3, which amounts to 30% increase. And we'll do the same for the slide animation. Now this graphical diagram here represents the logic that's going to control the player's animation behavior in the game. You can see that we have designed a specific sequence of animations for the player that are going to be played in a specific order and based on certain conditions. If we were to script the logic for this sequence of animations in C# ourselves, it would be a really long and messy script. However, the Unity Animator system or Mechanism has made it really simple to do that using these animation state machines as they are formally called by Unity. Okay, now we are fully done with our animator controller state machines diagram. What we need to do now is add an animator component to our player game object from the game object hierarchy. You can see that I already have an animator component attached to my player game object, and you probably have that too. This is because when we rigged our player model, Unity has automatically attached an animator component to our player game object. If for some reason you don't have an animator component attached to your player game object, then select your player game object from the hierarchy and go to Add Component and then look for Animator. Now go ahead and uncheck the Apply Root Motion setting from the Animator component. If you don't do that, then the player animations will look really strange, so be sure to do that. Finally, drag the player animator controller and drop it onto the controller field of our player animator component. Make sure that you save the changes in the editor. Now we're ready to script the behavior for our player. So, go to the scripts folder and open the player controller script. The first thing we're gonna do is create a variable of type animator and name it anim. Let's go to the start function and get a reference to the animator component that is attached to this game object, which is the player game object. Now we can access all the methods that the animator component has to offer, like playing our animations, for example. We'll start coding the jump animation first. So let's go up here and create a float, which we shall call jump force, and set it to 1.5 maybe. Now let's go to the player logic function and go to the vertical movement section of our code and write an if statement here. Let's see, if the user presses the space key and the character controller of the player is grounded, so these two ampersand signs mean AND in C#. So if the user presses the space key and the player is touching the ground, if these two conditions are met simultaneously, then execute the following piece of code, which is play the jump animation from our animator. So type anim dot set trigger, open a pair of parentheses, a pair of quotation marks, is jumping, semicolon. The name of the trigger inside the quotation marks is case sensitive, so be sure to write it exactly as you've written it in the animator controller. Now let's adjust the y component of our player vector variable. Type player vector dot equals, and now I'm going to use a formula that always works for me when I try to make the character controller jump. Type mathif dot square root, open a pair of parentheses, jump force times g value, semicolon. Now let's go up here and write an if statement that checks if the user has pressed the down arrow key, and now we'll set the sliding trigger from our animator. Also, the player should be grounded for him to be able to slide. Okay, I think this is good. And we're not going to concern ourselves with the running animation here in the script because it's the default case if you remember, so it doesn't need any trigger event. Let's save the changes to our script and test our game in the editor. And let's keep our animator window open so that we could see how our player animator controller loops through the different animation states in the game real time. Now let's play our game. Okay, the running animation seems smooth as butter, and you can see it being played in a loop in the animator window. Now if I hit the down arrow key, you can see the transition happening on the left to the slide animation state. And if I hit the space key, we transition to the jump animation state in the player animator controller. And then we circle back to the running animation state automatically. For some reason we are unable to slide beneath this obstacle. And these kinds of situations always happen in game development. You expect things to work out, but for some reason they don't. So let's think about what might be causing this problem. Let's pause our game and double click on our player game object from the hierarchy to see him where we paused in our game. Make sure that you have the gizmos turned on to see the different components attached to different game objects in the scene, including our character controller. I'm gonna pause the game as the player is sliding and look at our player's gizmos in the scene when he's at this obstacle. So it looks like our character controller capsule is what's preventing the player from passing through the obstacle. You can see that our player avatar is ducking down, but the character controller capsule, which is what's moving the player in the game, is too high to pass through. So let's lower the character controller center to 0.5 and make its height also 0.5 and get rid of its radius. These values seems like they're gonna allow both the player avatar and the character controller capsule to pass through this kind of obstacle in the game. Now please be mindful that these changes will not be applied to our character controller because we are in play mode. So do not actually adjust your character controller values from the previous original values. We'll instead adjust them in the player controller script. So let's go back to the player controller script and see what we can do. Since the sliding animation requires a little more work, we're gonna cut this line and paste it in a new function called doSliding that we're gonna create below. Before we set the trigger for the slide animation, we need to change the attributes of the character controller capsule so that it can allow the player to pass through the obstacle. So let's make the height of our character controller capsule 1 unit like we said earlier. And its new center is 0, 1/2, 0. And its radius is 0. With the new character controller capsule, we can now set the trigger for the sliding animation. But this change is temporary, right? Because once the player is done with his sliding action, the player character controller capsule should go back to its original size so that our game can continue functioning properly. So let's copy the attributes of the character controller capsule from here and paste them in a new function of type IEnumerator. And you'll see why we chose this type in a second. And call it re-enable character controller or CC. This function here is going to be in charge of resetting the original character controller capsule once the player sliding action is finished. So it should really be called reset CC, but we'll stick with the re-enable CC. So let's reset the original values of the player character controller capsule. The height was 2 units and the center was 0, 1, 0 And finally, its radius was 0.2. Now before we readjust our character controller capsule, we need to wait for the sliding animation to finish playing first. So let's go up here and write the following line of code. Yield, return, wait for seconds, open a pair of parentheses, and we'll wait for half a second before we execute the rest of the code in this function. It's showing us an error for some reason. Oh, we need to call the default constructor for the wait for seconds method by tapping new before it. So this line here says, wait for half a second before you execute the rest of the code in this function. Now let's call this function before the sliding trigger in the doSliding function. However, this function needs to be called in a special way. Particularly, it needs to be called as a coroutine. So type start coroutine, open a pair of parentheses, and let's call our reenable CC function. Now let's answer the question, what is a coroutine? Earlier in the course we had mentioned the C# is a language that executes the code inside it sequentially, line by line. But sometimes we want to execute the code concurrently or in parallel, not sequentially. This is a prime example of such need, because this function, reenable CC, is not going to stop the main update function, which is running the player logic function, from executing the rest of the code. It's going to be running in the background alongside the update function until it's time for it to be activated. Also, a coroutine in Unity has to be an IEnumerator type. That's why we made the reenable CC function of IEnumerator type. Okay, save the changes and go back to the editor. Let me just say one thing, I really love making this course. You're literally learning about all sorts of things relating to programming and game development in such a compact and direct way. And you're seeing it being applied to help us fix our game, not just in the abstract. Okay, let's go back to testing our game. Oops, it's giving us an error for some reason. I think this is the first error message we've had in this course. Let's read the error message. It says that there is an error on line 130 of the player control script. So let's go there and see what's wrong. Oh, I see, we need to put an F after the .2 to indicate that it's a float. Let's save the changes and go back to the editor. And by the way, Unity will not let you run your game if there is an error anywhere in your script. Okay, hit play. Let's hope our random logic gives us a sliding obstacle quickly. Okay, here's one. And voila. One thing I do like though is that it looks like the player is sliding into the bridge segments. So let's go to our player controller script and change the height of the character controller capsule while the player is sliding. Let's make it 1 instead. Save and go back. Okay, this looks flawless. One final thing, we forgot to make the player slide quickly after he jumps. So let's go to the animator window of our player animator controller and make a transition from the jump animation state to the slide animation state, and have it triggered by the sliding trigger, and it should be interrupted. Finally, let's go to the player controller script and remove the isGrounded condition from the if statement that checks for the down arrow key press. Save and go back. Hit play. Let's jump and then slide. Amazing, really. This marks the end of this tutorial. I really enjoyed making it. I have to say that it was longer than I anticipated it to be, but I feel like we've covered animations in game development and Unity's own animation system in a complete way, and our game looks much more alive right now. That's why I love animation. In the next tutorial, we're gonna implement a clearing fog effect that clears as the player comes close to it, and also we'll add a surrounding water visual effect so that you could really feel the danger of falling down and drowning. Thank you, and I'll catch you later.